everyone. So now today also I am doing the class for class 12 science. The topic is again inverse circular function. That is, we are continuing the same problems from inverse circular function. So in the last class we did how to find out the principal values of given inverse circular functions, right? So today we'll do some more problems using formula, right? So now in the last class we did up to question number 18 and 19, that is 19 number 1 problem was done on the first online class. So today we are doing this question number 20. So prove that. You have to prove this LHS is equal to RHS using the formula. Okay. So number 20 is tan inverse half plus tan inverse 2 by 11 is equal to tan inverse 3 by 4. You have to prove LHS is equal to RHS, right? So let us write down LHS. So left hand side is equal to tan inverse half plus tan inverse 2 by 11. So which formula is used in this case? So you have done this type of formula in this chapter, that is tan inverse x plus tan inverse y. So tan inverse x plus tan inverse y is equal to, what is that formula? It is tan inverse x plus y upon 1 minus xy. This is the formula. So this is very important formula, that is tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy. So you have to memorize this formula in both ways, that is from the left hand side as well as right hand side. Okay, so if you have tan inverse x plus tan inverse y, you should write tan inverse within bracket x plus y in the numerator divided by 1 minus xy, or you have to remember this formula in this way also, that is tan inverse within bracket in the numerator x plus y upon 1 minus xy is equal to tan inverse x plus tan inverse y. If there is plus sign here, plus sign in the numerator and negative sign in the denominator. So let us use the formula here. What is the value for x in this case? Half. What is the value for y in this case? 2 by 11, right? So is equal to tan inverse, what is x plus y? X is half plus what is y? 2 by 11 divided by 1 minus what is x? Half into what is y? 2 by 11. So now in this case no need of simplifying it. Cancel गर्दा पनि हुन्छ, क्यान्सल गर्दा पनि भयो, क्यान्सल नगर्दा पनि हुन्छ. क्यान्सल गरेन भने अझै सजिलो भएर जान्छ. बुझ्यो? So now let's simplify it. Tan inverse. So what's the LCM here? 2 and 11 LCM is 22. 2 and 11 LCM is 22. Now 22 is divided by 2. That is 11. 11 ones are 11. Plus next 22 is divided by this 11. This LCM is divided by 11. That is 2 and 2 2s are 4. Now in the denominator 11 2s are 22. Below 1 there is 1. What's the LCM of 22 and 1? That is also 22. So 22 ones are 22 minus this is 2. This bracket is closed. Now you can simplify it further, right? So let's simplify it further now. So here 22 gets cancels, right? So which is equal to tan inverse. So what is there within bracket? 11 plus 4, 15 divided by 22 minus 2 is 20. 22 minus 2 is 20, right? So you can cancel it. 15 by 20. You can convert it into lowest fraction. You can cancel it by 5. 5 3s are 15. 5 4s are 20. Which is equal to tan inverse. This is 3 upon 4. So that is the answer. So which is equal to right hand side. So which is proved. Proved. Right? So this is the answer. So you can copy it. So now we will do question number 21. That is, you have to prove that cos inverse 1 upon root 5 plus cos inverse 2 upon root over 5 is equal to pi by 2. Right? So let us prove it now. So LHS. So LHS is equal to cos inverse 1 by root 5 plus cos inverse 2 by root 5. Right? So now in this case you have to use the formula of cos inverse x plus cos inverse y. You should know the formula. So now let us write down the formula for cos inverse x plus cos inverse y, right? So cos inverse x plus cos inverse y is equal to, what is the formula? Now I think you know it. Its formula is cos inverse xy minus, if it is plus there should be minus if both are cos inverse x and cos inverse y, right? So minus root under, this is 1 minus x square into 1 minus y square. Okay, so यो पनि तिमीले याद गर्नुपर्छ. Cos inverse x plus cos inverse y is equal to cos inverse within second bracket xy minus root under 1 minus x square into 1 minus y square. Second bracket is closed. Okay, now same formula is used here. What is the value for x here? 1 by root 5. What is the value for y here? It is 2 by root 5. So let us use the formula. So is equal to cos inverse within second bracket. What is x? Here x is 1 by root 5 into what is y? It is 2 by root 5. Right? Next, minus sign is there. Minus root over. It is 1 minus x square. 1 minus, what is x square? 1 by root 5 whole square. That is 1 by 5 into 1 minus, what is y square? It is 2 by root over 5 whole square. What is it? It is 4 by 5. So it is 4 by 5. So here second bracket is closed. Is that clear to all of you? So is equal to cos inverse within second bracket. Now let us write, this is 2 ones are 2 divided by root 5 into root 5 is 5. Root 5 into root 5 is root over 25, which is equal to 5, right? So minus within square root, again you can simplify it. 5 ones are 5 minus 1, 4 by 5, right? Into, again 5 ones are 5 minus 4, that is your 1 by 5, right? Now let us simplify it further. Let us simplify it further now, which is equal to cos inverse within bracket. So it is 2 by 5, right? So it is 2 by 5 minus. So in the numerator, within square root, 4 into 1 is 4. What is the square root of 4? 2. 2 divided by, what is square root of 5 into 5? That is 5. So 2 by 5 minus 2 by 5, you can cancel them. They are subtracted, which is equal to 0. So cos inverse 0. Now you have to find out the principal value of cos inverse 0. Principal value means least value of cos inverse 0. You know how to find it. We did it in the last online class, isn't it? So if there is cos inverse, you should write cos. Cos of which angle is 0? It should be in the form cos inverse cos x, isn't it? So cos of which angle is 0? Cos pi by 2, right? Cos pi by 2 is 0, isn't it? You know that. So which is equal to cos inverse within bracket cos pi by 2. Cos inverse 0. Cos ko kun cha angle cha 0 ho bhandabari cos pi by 2. So write down the angle in terms of radian. So what is cos inverse cos pi by 2? Which is equal to pi by 2. So it is proved. Which is equal to right hand side. So it is proved. Okay. So you can copy it also. Or if you know the formula, you can do it yourself, right? So now we will do question number 23 and 22 will be a homework. I'll give you the question, right? So this is question number 23. Now let us prove it. Let us prove LHS is equal to RHS. Okay? But here it is given as 2 tan inverse 1 upon 5. That is on the left hand side. 2 tan inverse 1 upon 5 plus tan inverse 1 upon 8 is equal to tan inverse 4 by 7. You have to prove this LHS is equal to RHS. So first of all, you have to use the formula in this case. So which formula is used here? This is 2 tan inverse x, isn't it? So I think you know it now. What is 2 tan inverse x formula? 2 tan inverse x is equal to, what was the formula? It is tan inverse 2x upon 1 minus x squared. This is the formula that you can use for the first term. Okay, so let us use this formula on the left hand side. So now let us write down LHS. LHS is equal to 2 tan inverse 1 upon 5 plus tan inverse 1 upon 8. So let us use the formula for this first term. Let us use that one. So which is equal to tan inverse. What is the value for x in this case? What is the value for x here? In this case, x is equal to 1 by 5. So use that formula. 2 into, what is x here? 1 by 5 divided by 1 minus, what is x square? Here x square is 1 by 5 whole square, which is equal to 1 upon 25. Okay, you have understood? So next, plus tan inverse 1 upon 8. Now let us simplify it. Is equal to tan inverse, within bracket it is 2 by 5 divided by. Now simplify the denominator. 25 ones are 25 minus 1. It is 24 by 25. Then plus second term, keep it same. That is tan inverse 1 upon 8. Right? So next, which is equal to tan inverse within bracket, you can cancel here. 2 ones are 2, 24 by 12 times. 5 ones are 5, 25 by how many times? 5 times, right? So next, tan inverse. Now this is 1 upon 12 by 5. When this 12 by 5 goes up in the numerator, it becomes upside down, isn't it? Mathi ko tolo, tolo ko mathi. That is 5 by 12. It is 5 by 12, right? Then plus tan inverse 1 by 8. Plus tan inverse 1 by 8. Is it understood now? So now you can use the same formula that we have done in the previous problem. That is tan inverse x plus tan inverse y. Now you should know the formula. Tan inverse x plus tan inverse y is equal to what? Tan inverse within bracket x plus y upon 1 minus xy. Okay? So here x is 5 by 12 and what is y? 1 by 8. Right? So is equal to tan inverse within bracket. In the numerator, what is x? 5 by 12 plus what is y? 1 upon 8 whole divided by 1 minus xy. 1 minus what is x? 5 by 12 into what is y? 1 upon 8. Is that understood now? Okay. So now let us simplify it again. You can simplify it further. Tan inverse within bracket. Now in the numerator, what's the LCM of 12 and 8? Can you tell me? What's the LCM of 12 and 8? You know how to find the LCM, isn't it? So it will be 24. You know how to simplify it. How to get the LCM, isn't it? So 24 LCM lie, you 12 will divide on it. 24 is divided by 12. That it is 2. 2 5s are. Now multiply by 5 here. 2 5s are 10 plus. Divide 24 by 8. It is 3 times. 3 into 1 is 3. Right? So divided by. Is that right? Now in the denominator, what's the LCM? 12 into 8. This is 96. This is your 96. Okay? 12 8s are 96. So 96 ones are 96, then minus 5. right? Now again you have to simplify it. So again you have to simplify this left hand side. So which is equal to tan inverse, now in the numerator 10 plus 3, 13 divided by 24, next 96 minus 5, 91 divided by 96, okay? So which is equal to, now again you have to simplify this fraction. In the numerator there is a fraction, in the denominator also there is a fraction. So tan inverse within bracket 13 by 24 into 96 by 91. You know that when this denominator goes up in the numerator, it becomes 96 by 91. That means upside down. So 24 ones are 24, 24 fours are 96, isn't it? 13 ones are 13, 13 sevens are 91. You know that, isn't it? 24 ले 96 लाई पुरै भाग जान्छ 4 times. 13 ले 91 लाई पुरै भाग जान्छ, that is 7. So which is equal to tan inverse, this is 4 upon 7. So we have got this right hand side. So it is proved. So we have done number 23. Okay. So now I will give you the homework. Okay. So you can copy it. So now these are your homework. I'll give you the hint also. That is, this homework is from Sailendra book. Exercise 4, 2 mark section and page number 97. Right? So 19 number 2 is, you have to express tan inverse x, that is, this x is always greater than 0, x is always positive, that means in terms of all the inverse circular functions. So we did 19 number 1 in the first online class. So likewise, you can do this 19 number 2. You have to convert this tan inverse x into other inverse circular functions. That means tan inverse x should be converted into cot inverse, sine inverse, cosec inverse, cos inverse, as well as sec inverse. Okay, you can do it. So 19 number 2 is your homework. Then these are also your homework. Prove that. Number 22, 2 tan inverse half is equal to tan inverse 4 by 3. You can use the formula 2 tan inverse x here. You can prove it. Now in this case, in number 24, sine inverse 3 by 5 plus sine inverse 8 by 17 is equal to sine inverse 77 by 85. So write on left hand side and use the formula sine inverse x plus sine inverse y. Okay. In case of 25 also, it is cos inverse 15 by 17 plus cos inverse 3 by 5 is equal to cos inverse 13 by 85. So in this case also, you write on left hand side first and then use the formula of cos inverse x plus cos inverse y. Right? So next, number 26, also you can do it. Prove it. Tan inverse a plus cot inverse b is equal to cot inverse b minus a divided by 1 plus ab. Now in this case, convert this tan inverse a into cot inverse. You know how to convert tan inverse a into cot inverse. It is cot inverse 1 upon a, isn't it? This a becomes upside down. That is cot inverse 1 upon a plus cot inverse b. Now in this case, use the formula of cot inverse x plus cot inverse y. So you can prove this LHS is equal to RHS. Is it clear to all of you? So you can do it at home. Your homework. Now we'll do the next question. Okay, these are your homework. Now we'll do question number 27. First you copy it. So now let's do number 27. Here also you have to prove that 4 into within bracket cot inverse 3 plus cosec inverse root 5 bracket close is equal to pi. So this type of question you may get in HS also. Okay, so this is also important question. So now in this case you have proved this left hand side is equal to only pi is there. Okay, but in this case these are two different inverse circular functions. So you have to convert them into same inverse circular function. So you know the formula, that is which formula is much more easier, that is tan inverse x plus tan inverse y or tan inverse x minus tan inverse y. That is much more easier than other formulae, right? Tan inverse x plus tan inverse y and tan inverse x minus tan inverse y. So let us convert this cot inverse 3 into tan inverse and cosec inverse root 5 into tan inverse. Okay, then this is tan inverse x and this will be tan inverse y. So you can use the formula of tan inverse x plus tan inverse y to prove this LHS is equal to RHS. Okay, so let us write down left hand side. So LHS is equal to 4 within bracket cot inverse 3 plus cosec inverse, this is your root 5, right? So you can convert this cot inverse 3 into tan inverse. What is that in terms of tan inverse? It is, you know it, tan inverse 1 by 3, right? So is equal to 4 within bracket, this is tan inverse 1 upon 3 plus. So now let us write down this cosec inverse root 5. You cannot directly convert this cosec inverse root 5 into tan inverse. You have to simplify it. Now let us convert this cosec inverse root over 5 into tan inverse. Okay. So let us assume, let cosec inverse root 5 is equal to theta, right? Now cosec inverse, take it to the right hand side, it becomes cosec. That is root over 5 is equal to cosec theta, right? So now, or you can write cosec theta is equal to root over 5. Is that clear to all of you? And so now from cosec theta you have to get the value for tan theta, because we are converting this cosec inverse root over 5 into tan inverse. Okay, so before that, from cosec theta you can get the value for cot theta using a formula, isn't it? That formula is, what is the formula? Cosec square theta is equal to 1 plus cot square theta. But in this case cosec theta is given as root 5, so you have to find out the value for cot theta. So what is the formula for cot square theta now? You know, what is the formula for cot square theta? Tell me. So it is cosec square theta minus 1, right? So it is cosec square theta minus 1. This is the formula. So this is your formula, right? So now from cosec theta you have to get the value for cot theta. So you have to use this formula. So right now we know that now what is cot theta is equal to, it is root over, isn't it? If it is cot square theta is equal to cosec square theta minus 1, then cot theta is equal to square root. Since it is positive, this cot theta is also positive. So cot theta is equal to, within square root, what do we write? It is cosec square theta minus 1. Now put the value of cosec theta. What is cosec theta? It is root 5. So or cot theta is equal to root over, how much is that now? It is root over 5 whole square, root over 5 whole square minus 1, right? Or cot theta is equal to root over, this is your, what is root over 5 whole square? Root over 5 whole square is root 5 into root 5. Root 25, which is root 5, so it is minus 1. Or cot theta is equal to root over 4, or that means what is cot theta is equal to 2. But you have to find out the value for tan theta, because we are converting this cosec inverse root over 5 into what? Into what? Tan inverse. Is that clear now? So now in the next step, let us find out the value for tan theta. You know what is cot theta in terms of tan theta? It is 1 by tan theta. So it is 1 by tan theta is equal to 2. So below 2 there is 1. So what is the value for tan theta? So tan theta is equal to half. You can convert, that is, you can invert both the sides here to get the value for tan theta. If you invert left hand side, you have to invert right hand side also. That is, tan theta is equal to 1 upon 2. Or, what is the value for theta now? Tan inverse half. That is, when tan goes to the right hand side, it becomes tan inverse. So this is theta. What is the value for theta? Tan inverse half. Actually, we had assumed theta as cosec inverse root 5. That is, cosec inverse root 5 is equal to theta, and theta is equal to tan inverse half. That means cosec inverse root 5 and tan inverse half are equal. That means, therefore, cosec inverse root 5 is equal to, how much is it? It is tan inverse half. Understood now? So now you have to write down the value of cosec inverse root 5 on the left hand side. Okay? So now write down left hand side again. Write down LHS again. So LHS was, what was LHS? It was 4 within bracket tan inverse 1/3. We had converted this cot inverse 3 in terms of tan inverse, which is tan inverse 1/3, plus just now we got the value for cosec inverse root 5, which is equal to tan inverse half, plus it is tan inverse 1 upon 2. Okay, now you can easily use the formula of tan inverse x plus tan inverse y, isn't it? So let us use the formula of tan inverse x plus tan inverse y. What is the formula? Is equal to tan inverse in the numerator x plus y whole upon 1 minus xy, right? So is equal to 4 into tan inverse within bracket. What is x in this case? 1/3. Plus what is y in this case? Half, whole divided by 1 minus, what is x into y? 1 upon 3 into 1 upon 2. So here the bracket is closed. So which is equal to 4 into tan inverse. So now within bracket, what's the LCM in the numerator? In the numerator, 3 and 2 is there. What is the LCM? 6. 6 is divided by 3. 2 ones are 2. You know how to simplify it. Plus 6 is divided by 2. That is 3. 3 ones are 3. In the denominator, what's the LCM? What's the LCM? 6. 3 2s are 6. 6 ones are 6. Minus 1. Right? So here you can cancel this. 6 gets cancels. Okay? Is it clear to all of you? So I think we have understood it. Okay? So now next. So now in the next step, which is equal to 4 tan inverse. So within bracket, 2 plus 3 is 5 divided by, what is 6 minus 1? What is that? 6 minus 1? 6 minus 1 is also 5. So here you can cancel them, which is equal to 4 tan inverse 1. Is that clear now? So now let us find out the value of this inverse circular function. That means you have to find out the principal value. Is that clear? You have to find out the principal value of tan inverse 1. You know how to find it, isn't it? If this is tan inverse, you should write 1 in terms of tan. That means tan of which least angle is 1? Pi by 4. Tan pi by 4, isn't it? Tan pi by 4. So which is equal to 4 tan inverse. Now in this case, you have to convert into tan inverse tan x form. X is the least value. Tan inverse tan x form. If you write tan inverse tan x, you should write x. You can write x, isn't it? So instead of 1, what will you write? Tan pi by 4. So if it is tan inverse, you should write 1 in terms of tan. That is tan pi by 4 is always 1. So it is tan pi by 4. Right? So which is equal to 4 into, what is tan inverse tan pi by 4? Pi by 4. Right? So your 4 gets cancels, which is equal to, what is the answer? What is the answer? That is pi. So which is equal to right hand side. So we have proved it. proved. Understood? So you can copy it. So now, this question number 28 is your homework. It is same as question number, it is similar to question number 27. You have to prove that sin inverse 1 by root 5 plus cot inverse 3 is equal to pi by 4. You write on left hand side, then convert this sin inverse 1 by root 5 into tan inverse, and cot inverse 3 you can convert into tan inverse. Okay, so then you can use that formula, tan inverse x plus tan inverse y is equal to tan inverse x plus y upon x 1 upon tan inverse x plus y upon 1 minus xy. That is, tan inverse x plus tan inverse y is equal to tan inverse within bracket x plus y upon, in the denominator, 1 minus xy. So you can use this formula to prove it. It is similar to question number 27. You can do it. Okay, so you can copy this question. So now let us prove that number 29. Tan inverse root over x is equal to half cos inverse 1 minus x upon 1 plus x. So from which side will it be easier for you to prove it? From right hand side. You can prove it from right hand side. Okay, and let us do trigonometrical substitution. Okay, we should do here trigonometrical substitution as we have proved the formula, isn't it? So if you do here trigonometrical substitution, it will be easier for you to simplify. Okay, and in case of differentiation in calculus, you will do differentiation. In integral calculus, you should do integration also. In that case also, you should know how to do the trigonometrical substitution. Okay, so this is very, very important chapter, this inverse circular function, right? So now let us prove it from right hand side, right? So RHS is equal to tan inverse root over x, RHS is equal to what? Half cos inverse 1 minus x divided by 1 plus x. Okay, now we have to do the trigonometric substitution for x here. Which trigonometric function will you write for x so that we can have here cos inverse cos form? You should do the trigonometric substitution for x here. Okay, so which trigonometric function will you write for x so that we can have here cos inverse cos theta form? You may not get cos theta, but it should be in the form of cos inverse cos form, right? So you know the formula. One formula is there for cos 2 theta. Cos 2 theta, you know that 1 minus tan square theta, 1 minus tan square theta divided by 1 plus tan square theta. You should know this formula. This formula is from multiple angles. That is cos 2 theta. Cos 2 theta ko charta formulas hai. There are 4 formulae for cos 2 theta. Number 1 formula is cos 2 theta is equal to cos square theta minus sin square theta. Second formula is cos 2 theta is equal to 2 cos square theta minus 1. Third formula is cos 2 theta is equal to 1 minus 2 sin square theta. And this is the fourth formula, that is cos 2 theta is equal to 1 minus tan square theta upon 1 plus tan square theta. Now on the right hand side it is given 1 minus x upon 1 plus x. Okay, so what should we write for x here so that we can use the formula cos 2 theta? If you write x is equal to tan square theta, you can use this formula, isn't it? So here the trigonometric substitution is x is equal to tan square theta. You should understand this problem, right? So let x is equal to tan square theta, right? So let us simplify. Let us get the value for theta. First of all, you should get the value for tan theta here. Tan theta is equal to, if tan square theta is equal to x, what is tan theta is equal to? Root x. It is always positive, right? So what is the value for theta now? Theta is equal to, now tan goes to the right hand side, it becomes tan inverse root x. this is tan inverse root over x, right? So we are using this formula here, okay? Now this right hand side becomes, so RHS is equal to, now on the right hand side you can put the value for x that we had assumed here. What was the value for x? Tan square theta. So right hand side is equal to half cos inverse within bracket 1 minus what is the value for x here? Tan square theta. It is tan square theta divided by 1 plus tan square theta, 1 plus tan square theta, right? So which is equal to, this is half cos inverse. So within bracket, what is the formula for 1 minus tan square theta divided by 1 plus tan square theta? It is cos 2 theta. So that's why you have to remember the formula from both the sides, from LHS also, from RHS also. That is cos 2 theta is equal to, what is the formula? 1 minus tan square theta upon 1 plus tan square theta. Or what is the formula for 1 minus tan square theta upon 1 plus tan square theta? Which is equal to cos 2 theta. So that you can write cos 2 theta here. So it is cos 2 theta. So you know from this chapter the formula, what is cos inverse cos x? X. So in this case it is half into 2 theta. It is half into 2 theta. Is it clear now? So here 2 gets cancels, which is equal to what? Theta. But what is the value for theta in this case? It is tan inverse root x. So here theta. So what was theta actually? It is tan inverse root x, which is equal to tan inverse root over x, proved. So which is equal to left hand side. So we have proved this result. Understood? So you can copy it. Now we'll do the next question, right? So now again, this question number 30 is your homework, because these 30 and 31 are of similar type problems, right? I'll do number 31. You can easily do question number 30. If you understand 31, you can easily do question number 30. So 30 is your homework. So number 30 is sec square within bracket tan inverse 3 plus cosec square within bracket cot inverse 4 is equal to 27. You can prove it at home. So similar question is there, 31, we'll do it here, 31, okay? So in 31, you have to prove that sec square cot inverse 2 plus cosec square tan inverse 3 is equal to 2, 13 by 36. That is your mixed fraction is there, right? So let us prove it. So let us write down left hand side is equal to. So this left hand side, if you have sec square theta, you can write sec theta whole square, isn't it? If you have sec square theta, you can write sec theta whole square. So likewise, here also you can write sec cot inverse 2 whole square, right? Plus here also you can write cosec within bracket tan inverse 3 whole square, okay? Now let us find the value for sec cot inverse 2. First of all, let us find out the value for sec cot inverse 2. So take it outside. Sec cot inverse 2. The सबभन्दा पहिला हामी के को भ्यालु निकाल्छौं, sec cot inverse 2 को भ्यालु चाहिँ हामी पहिला निकालिहाल्छौं यो, ठीक छ? त cot inverse 2 लाई हामी सपोज गरौँ, let cot inverse 2 is equal to theta. So what is 2 is equal to? So cot inverse goes to the right hand side, it becomes cot theta. That is cot theta is equal to what? 2. Right? So we have got the value for cot theta, which is equal to 2. Right? So next. Now next one is, now if you write theta for cot inverse 2, it becomes sec theta, isn't it? So let us find out the value for sec theta. So sec theta. So you know the formula of sec square theta is equal to 1 plus tan square, you know that, isn't it? So let us write down the formula here. So sec square theta is equal to 1 plus tan square theta. You have done it in class 10. What is the value for sec theta now? Sec theta is equal to root over, this is 1 plus tan square theta, right? So we can use the formula here, which is equal to root over 1 plus, this is tan square theta. Is that clear? But here we have got the value for cot theta. You know how to write tan theta in terms of cot theta, isn't it? So is equal to root over, this will be 1 plus, what is tan theta in terms of cot? 1 by cot, isn't it? Tan theta is equal to 1 by cot theta. Here 1 by, this is cot square theta. Is that clear to all of you? Okay. So next. So which is equal to root over 1 plus 1 upon, what was the value for cot theta actually? It is 2 whole square, isn't it? So write down 2 whole square is equal to root over, it is root over 1 plus 1/4 is equal to root over, this is 5 upon 4. This is your 5 by 4. That is root over 5 by 4 is the value for sec theta. Now let us write down. This root over 5 by 4 is the value of sec theta. Therefore, sec theta is equal to root over 5 by 4. Or sec. Actually, what was theta? Actually, theta was cot inverse 2, isn't it? You can sec it in the previous steps. You can sec it. That is, theta was cot inverse 2. So, cot inverse 2, which is equal to square root of 5 by 4. So what is the value for the first term? That is sec cot inverse 2 ko tyaha hamro square root of 5 by 4. So similarly you can get the value for this cosec tan inverse 3 whole square. So first of all get the value for cosec of tan inverse 3. So now again, since, let us take it outside again. Cosec tan inverse 3. Cosec tan inverse 3, right? Now let us assume, you have to get the value for cosec within bracket tan inverse 3. Let us assume the value for tan inverse 3. Let tan inverse 3 is equal to, what will you write? Let us write it as alpha, right? This is alpha. Or 3 is equal to tan inverse goes to the right hand side, becomes tan alpha. Or tan alpha is equal to, how much is it? Tan alpha is equal to 3, right? Next, that means this becomes cosec alpha. If tan inverse 3 is equal to alpha, then this becomes cosec alpha. Therefore, you have to get the value for cosec alpha. So now you know the formula cosec alpha in terms of cot, isn't it? So cosec square alpha is equal to 1 plus cot square alpha, right? Or cosec alpha is equal to root over, this is 1 plus cot square alpha. You can use that formula. But you should know the formula cosec square alpha is equal to 1 plus cot square alpha. That is, this formula is also done in class 10. Okay. So what is cosec alpha is equal to root under 1 plus cot square alpha. So is equal to root over, this one is 1 plus cot square alpha. Right? So this is the formula. But in this case, the value for tan alpha is known, that is 3. So you can convert this cot square alpha into tan square alpha, isn't it? That is, cot alpha is 1 by tan alpha. So cot square alpha is 1 by tan square alpha. So let us write down. Is equal to root over 1 plus 1 upon, this is your tan square alpha. What is tan alpha? It is 3. Root over 1 plus 1 upon 3 whole square. Right? Let us simplify it. So it is root over 1 plus 1 by 9 is equal to root over 9 1 9 plus 1. That is 10 by 9. So what is the value for cosec alpha? It is square root of 10 by 9. Okay. So therefore, let us write down here cosec alpha is equal to root over 10 by 9. That is square root. Within square root there is 10 by 9. But what was alpha actually? This alpha was assumed as tan inverse 3. So or cosec within bracket. What is alpha? It is tan inverse 3. Tan inverse 3 is equal to within root. This is 10 upon 9. So root over 10 by 9 is the value of cosec tan inverse 3. Okay. So now write down LHS, left hand side. Now we will write down the left hand side. Okay. So now what was the left hand side? Let us write down the left hand side now. So left hand side was, what was the left hand side here? It was sec cot inverse 2 whole square, sec cot inverse 2 whole square plus cosec tan inverse 3 whole square. This was the left hand side. So now can you tell me what was sec cot inverse 2? What was the value for sec cot inverse 2? Can you tell me what is it? I just asked you the value for sec cot inverse 2, isn't it? What is it? Sec cot inverse 2 is equal to within square root 5 by 4. It was that. What is the value for sec cot inverse 2? It is square root 5 by 4. So let us write down here. Within square root 5 by 4 whole square plus, right? What was the value for cosec tan inverse 3? It is root over 10 by 9 whole square, right? So which is equal to square root 5 by 4 whole square is 5 by 4 plus, oh this is whole square root, not root over 10 by 9. That is square root, within square root it is 10 by 9, right? That is cosec tan inverse 3 is equal to within square root 10 by 9. So here also within square root, whole square root, within whole square root there is 10 by 9. So what is square root whole square? Square root will be eliminated. You will get 10 upon 9. Is that clear to all of you? So what's the LCM? 4 and 9. What's the LCM? It is 36. This LCM is divided by 4. That is 9. 9 5s are 45. Plus again this LCM 36 is divided by 9. 4. 9 4s are 36. So this 4 should be multiplied by 10. That is 40. Which is equal to 85 divided by 36. Okay. Now let us write it in terms of mixed fraction. Let us divide it here in the rough work. This 85 should be divided by 36. So 2 times 2 6 are 12. 2 1 3 2 are 6 plus 1 is 7. So what is 5 minus 2? 3. 8 minus 7 is 1. So how will you write it in terms of fraction? That is 2. What is the remainder? 13 divided. What is the divisor? This is 36. So that is root. That is LHS is equal to RHS, where RHS is equal to 2 13 by 36. Is it correct? Yes. 2 13 by 36. So similarly you can do that problem number 30. I gave you, before I did this problem, I gave you that problem. That is question number 30. That is your homework, right? So now I think I've understood it, right? You do the homework also. So this was just for today. We'll do more problems in the next class. Okay. So thank you.